today, what we're going to do is we're going to talk about GeoGraphix and GVERSE in the cloud, and we'll just go over the agenda here real quick. We'll go over the cloud itself. The cloud is sort of a nebulous term for folks, so we'll sort of try to define what it is and what it isn't. We'll discuss a proof of concept that LMKR embarked on using cloud machines. We wanted to figure out how well GeoGraphix and our GVERSE applications worked when they were set up in a cloud environment. And finally, we'll do a demo at the end. So let's get started. So the cloud, so what is it? This is sort of an academic definition. It's a generalized term for the delivery of hosted services over the internet. And this can take a number of forms. It could be an application, so something like Salesforce. It could also be a service. For instance, a lot of people use Google Drive for cloud storage. How we're using it is we're actually requisitioning machines from a cloud vendor, and we're using those machines as our own machines and renting the space, I guess, or renting the machines, and then setting up GeoGraphix and GVERSE on those machines and seeing how well it works. Access is through the internet, so you can either access those machines through your browser, or you can access them through a little utility that the vendor provides. Basically, it's the same thing. So what it's not, the cloud is not Citrix and it's not VMware. These are server-side technologies that offload computing to a centralized data server. This is often supported by visualization software. GeoGraphix and GVERSE runs very well on Citrix. Over the years, a lot of folks have moved to Citrix. It's a wonderful technology, but that's not really what we're talking about here. We're talking about requisitioning machines. So your machine is on the internet someplace, probably in a different state, and you're using that machine remotely. So cloud computing sort of taken the world by storm, especially in the last couple of years. The term cloud has been around for a very long time, probably 10 years now, but there are a lot of advantages to it. One big advantage, and the thing I probably like the most, is that it makes your computing resources very accessible. In other words, you can access your machine via a tablet, a netbook, an iPhone, a very underpowered computer, pretty much anywhere in the world that you want. It makes it very, very convenient, especially for those of us who are mobile or on the road a lot. It's also scalable, and I know the IT folks on the call appreciate this. You can gin up a new machine very quickly when someone joins your organization, or conversely, you can go ahead and power down that machine, get rid of that machine when you need to. It's also increasingly reliable. I read the other day that Amazon Web Services is now touting 99.9999% reliability. And to put that in perspective, that means your network will be down on average 6 seconds per year. And there's not a whole lot of network administrators out there that can say that their network's going to be down only 6 seconds per year on average. So reliability has improved dramatically. And these machines can be added to your own AD domain. So when you log into the machine, you're logging in with your AD credentials, just like you would log in to a machine at work. They are also able to access localized services. So for instance, if you needed to print to a local print service from a machine in the cloud, you would be able to do that. And they're secure. I think security has always been it's been concerning to a lot of folks when they think about cloud computing. How secure is it actually? It's turns out pretty darn secure. Amazon, Microsoft with Azure, and Google, those machines are pretty secure because their business depends on it. Oftentimes more secure in some cases than we can make our own networks. There are a few disadvantages still. One of the biggest disadvantages has been performance with high-end CAD and graphics. And unfortunately, those are the types of applications that we use as geologists and geophysicists. We interpret seismic, we run geomodeling packages, a lot of 3D graphics are involved, and oftentimes the cloud has proved really choppy and the frame rates have proved not very good. So that has been a concern, but I think as you'll see as this demo goes along, we've allayed those concerns to a great extent. There's also compliance violations, and really this comes down to agreements with third parties or vendors or partners where you're required to keep your data on premises. Again, things are changing out there. Both the federal government and the state of California have adopted guidelines for putting state or federal information on the cloud. And these guidelines are National Institutes of Standards and Technologies guidelines, and now it's an actual standard. And the three big cloud providers, Azure, Microsoft Azure, Amazon, and Google, all certify to those standards. So even the government is putting your information on the cloud, good or bad. But again, I think it's very secure. And there's also low bandwidth and loss of internet connection. Because you're accessing these services remotely via an internet connection, if you lose your internet connection, your bandwidth becomes very bad. Your performance obviously is going to suffer. I don't really put much stock in losing your internet connection in a wired world, in the wired world we live in right now. I mean, short of the zombie apocalypse, I don't think that's really going to happen. And if it does, we're going to have worse things to think about. However, low bandwidth can be a problem. It takes about, what we found is that it takes about 10 to 15 megabits per second on your internet connection in order to get a good connection to a cloud machine and run high-end graphics. Again, to put that in perspective, you're usually getting 40 to 70 on your local internet at home. And from our cloud machines, we get 100 megabits per second. So in general, it's not a problem. And I think it'll be even less of a problem in the future as 5G networks come into force. So who are the vendors? Well, there's three big ones. Microsoft, Amazon, and Google. These guys account for probably 90% of the cloud machines that are currently in use worldwide. They're ubiquitous. Generally, no matter where you are in the world, you're going to get a good connection to these machines, and they provide 99.999% uptime. So they're very reliable. There are also a bunch of smaller companies out there, Paperspace, WorkSpot, DigitalOcean, and there's a number of other ones. In fact, there's a lot of other companies that are offering cloud services. So what we did was we went ahead and we used Paperspace. And what we did was we set up our own network in the cloud and ran GeoGraphix off that network, both our GeoGraphix and our GVERSE applications. We set up 11 clients and one server, so we have our own network in the cloud. It was reasonably inexpensive. Some of the outside of the big three, I think the expenses are a little bit less. The cost is a little bit less. We pay about 50 cents an hour for a high-end machine with a powerful GPU, and then very powerful GPU, all the way down to about 7 cents an hour for a machine that you basically just want to surf the internet on. We also had to have very easy setup and configuration. We're using cloud machines here in North America, predominantly with our support and product management folks. And we really didn't want to have to ask our IT folks every time we wanted to restore a snapshot to get it to a different version of the software. And also, we wanted fast internet access. The machines that we're using on the cloud seem to have 100 megabits per second internet access. So when I surf, I tend to surf on my cloud machine. I don't surf on my office machine because I actually get faster internet on the cloud machine. So for the clients, every client has an Intel Xeon 260 gigahertz machine. It's a good gigahertz processor with 30 gigabytes of RAM. We use Windows Server 2016 or Windows 10. And each of these machines has an NVIDIA Quadro P4000 card with 8 gigabytes of GPU, excuse me. GPU has increased much faster than CPU over the last decade. And so a lot of high-end graphics now uses the GPU to do the processing. So we needed a good GPU. To put it again in perspective, if I had this machine on every single day, 52 weeks per year, 40 hours per week, it would cost about $1,000, which I think is a real good price. Amazon and AWS, the charges are a little bit more for a comparable machine, but the prices continue to come down. So let's go to the demo. So what we did, and I'll just escape out of here. What we did was took our, what I would consider to be our most demanding application. This is our new GeoVerse geophysics software for geophysics interpretation. So this is what's replacing the 3D part of SizeVision, and it's again written mostly on the GPU. So if we were going to run into problems with cloud computing, we would run into problems with this application. If you're using something like a spreadsheet application, or you're using Wellbase or another one of our applications, it really doesn't matter. The cloud works very, very well for those. But when you have applications that are highly GPU intensive and they require really fast frame rates, then you run into problems. Now, you guys, when I show you this demo, may see a little choppiness, but I can tell you that that choppiness is due to the GoToMeeting, the GoToWebinar application. I don't see any choppiness. So let's start here. This is just a seismic line, and this is a fairly large survey. This is not a small survey. It's a 25 gig survey. It's a medium-sized survey, you might say. This data is located in the North Sea. And so what I'm going to do is just add a lot of 3D objects to the scene. I'm going to go ahead and add, go ahead and add that. I'll add my 2D seismic. So now I hope you can see that the frame rates are really good for me. I hope you're not seeing too much choppiness, but again, I can assure you I don't see any choppiness at all. I'll go to the map and add some 3D scenes. So maybe I'll go to the map view here, and let's see here. I will go and add a probe, 3D probe, and I'll add that to the 3D view. Go back to the 3D view. You can see a probe has been added here. Go ahead and change that a little bit. And again, things look pretty darn good. We get better resolution and better frame rates off our cloud machines than we do off our office machines. These cloud machines are good machines, and they have good GPUs, but we get very, very little network latency. The machines that we use are located in California, and most of us are located in Houston or Denver or Calgary. I'll add a couple horizons here. Let's see, how about that one right there? Let's see, we have a horizon. I'll go ahead and add some contours to that horizon. Oops, move that out of the way a little bit. And I'll display my contours here. Again, pretty darn good resolution. I was very skeptical about this. One of our product managers, who's younger and the gamer. He came to me one day and said, I have a crappy computer at home, but I love using Paperspace because I can use these machines and I can game to my heart's content. And when I heard that, and this was last summer, we said, well, let's try it with GeoGraphix. So that's when we started the proof of concept. Ultimately, I think that LMKR will move to the cloud for most of its operations in North America. It just makes a lot more sense from a financial point of view, return on investment point of view, ROI, and just from a convenience point of view to go to the cloud for a lot of this than to continue to try to upgrade our internal hardware. So that's all I really want to show you guys today. I just wanted to show you what we did with the proof of concept. And if your organizations are considering moving to a cloud environment, to assure you that GeoGraphix and GVERSE does indeed work extremely well in the cloud. And we're eating our own dog food. We're using it. And we're using it very, very successfully. So that's all I have today, folks.